Question 1. A1 Roman. Define addressing mode. 1. Programming involves writing a set of instructions to perform specific tasks efficiently. 2. A program manipulates data by fetching, processing, and storing it in memory. 3. Addressing mode defines how and where data is accessed during instruction execution. 4. Choosing the right addressing mode improves speed, efficiency, and reusability of program.
So I'm going to list all the addressing modes in M68000 processor. The first one is register direct addressing. The first one is data register direct, and second is address register direct. And after that, immediate addressing. The first one is immediate and second is quick immediate. Third is absolute data addressing. The first one absolute short and second is absolute long. And the third one is program counter relative addressing. The first one is relative with displacement and second is relative with index and displacement. And the last one is register indirect addressing. The first one is register indirect, second post-increment register indirect, third is pre-decrement register indirect, fourth is register indirect with displacement, and the last one is register indirect with index.
Okay, this slide shows an example of a M68000 assembly program that performs addition of two numbers using three different addressing modes. First, we have two numbers, num1 equals 8 and num2 equals 12. The result will be stored in memory later. Then the first instruction uses immediate addressing, where the value 5 is directly moved into register D0. Next, the direct addressing mode is used to move the value from num1 into register D1. After that, we add D0 and D1, which gives us 13. Then we use register indirect addressing by loading the address of num2 into A0 and moving its value into D2. We add D2 with the previous result, giving us 25. Finally, we store the result, which is 25, into memory using the label result. And that's how this program performs addition using three addressing modes: immediate, direct, and register indirect.
For question for Roman, this is an example of an M68000 assembly program that performs subtraction using at least three addressing modes. In this program, I use immediate addressing, select addressing, and register direct addressing. The program starts memory location $2000. First, I move the value 20 into register T0 using immediate addressing. Then, I move the value stored at memory address $4000 into T1 using absolute addressing. After that, I perform subtraction using the instruction soap.w D0 T1, which means the value in D0 is subtract from D1. Finally, I store the result at memory address $5000. The program ends with the end statement. The result shows no error, which means the code runs correctly.
So now I'm going to describe every step of the assembly language of figure 1 using Easy68G simulator. The first one, org$2000, set the starting address of the program to $200. Second, move.w $4ab7 D1, load the immediate value $4ab7 into register D1. Third, not.w D1, invert all bits in register D1. And for the fourth, move.w $5e92 D3, load the immediate value $5e92 into register D3.
OR-WD2 D3, perform a bitewise OR between D2 and D3, store results in D3. Number 6. ADD-WD2 D3, add the contents of D2 to D3, store results in D3. Number 7. SUB WD2 D3. Subtract D2 from D3. Store result in D3. 8. END marks the end of the program. Today I am going to list all logical and arithmetic instructions in M68K assembly language. Logical instruction END OR EOR. EOR is exclusive OR and NOT. Arithmetic instruction ADD SUB MULS or MULU is multiple signed and unsigned. DIVS and DIVU is divide, signed and unsigned.
First, we start our program at memory location 1000 hexadecimal. So we write origin 1000 hexadecimal. Next, we move the binary value 10111111 into data register D0. So we write move word immediate 5F hexadecimal to data register D0. Then we move the hexadecimal value DAD8 into data register D1. So we say move word immediate DAD8 hexadecimal to data register D1. After that, we multiply the value in D1 with the value in D0. So we write multiply unsigned word D1 with D0. Finally, we add the octal value 1234 to the result in D0. So we say add word immediate 29C hexadecimal to data register D0, and then programs ends with the end statement.